Yes. Okay. 3.1 Exploring polynomial functions. So this whole chapter 3 is about polynomial functions. Okay, this is just an introduction. So a polynomial in one variable is an expression of the form. So you have a coefficient in front of, you may have coefficient in front of all those terms, and then you have the exponents. Okay, we usually put the polynomial functions in descending order. Therefore, you see the exponent as, you know, this one is n minus 1, and it goes less and less, and finally 2, x to the power of 1, and when x is x to the power of 0, right, that is equal to 1, so you only get coefficient at the end, if there is any, for that polynomial. So let's look at the characteristics of this, coefficients and the exponents. Look at the coefficients. So those coefficients can be any real number. Okay, so those a's, coefficients in front of the terms, can be any real numbers. It can be like square root of 3, or it can be a decimal value, which are all fine. But n, which is the exponent, must be whole number. Okay, so exponent can be 0, 1, 2, 3, 4, and it goes, but it cannot be a decimal value. It cannot be any other, let's say, square root of something or any other like that, irrational number. It cannot be. Okay, just the whole numbers, the exponents. Polynomials contain one variable. Powers are arranged in descending order. But if it is not arranged in descending order, you can put it in descending order. Polynomials with degree n have infinite differences that are constant. So let's say if you have a linear function, the first differences are the same. If you have a quadratic function, second differences are the same. So if you have a polynomial with highest degree of 3, we call them cubic functions. So they have third differences are the same. Okay, that's what it is talking about. The domain of all polynomial functions are XER. Okay, and range YER, it may have a maximum or minimum, but not both. Let's say trigonometric functions have a certain minimum and maximum. Okay, so they cannot be polynomial. So, but they may have certain maximum. Let's say a quadratic function. When you look at the vertex, if it, let's say, opens up, right? So then there's a minimum, right? One minimum value, but there's not at the same time minimum and maximum. So quadratic function is a polynomial. Okay, so polynomial functions don't have horizontal or vertical asymptote. Okay, and polynomial function with degree 0 is a horizontal line. Well, that should make sense, right? So if the degree is 0, so this gives you 1, so that is multiplied by any coefficient, so you get, let's say, y equals 5. X to the power of 0 gives you y equals 5, and that would be horizontal line. Now, example 1, we are going to identify the polynomial functions. Okay, so from a to n, let's go. So which of them are polynomial? Let's look at a. Is this a polynomial?
Yes.
Yes, right, because x has a power of 1, which is integer. So the coefficient is root 3, but that's fine, right? We said that those coefficients could be any real number, so that's fine. So that is a polynomial. Look at b.
No.
Yes.
Yeah.
Right, because see, x to the power of 5 is a whole number, and same thing with 2 is a whole number, so that's fine. This is 3 to the power of 1 over 2, but that number is the coefficient, so this is still a polynomial. How about c? No, because power of x is kind of 1 over 2, right? Square root of x is a power of 1 over 2, so that is not a polynomial. Okay, d, cos x. No, because it has a minimum and maximum, and we should not have it for the polynomial, so not a polynomial. E, no, it has a horizontal asymptote, right? All exponential functions have horizontal asymptote, and polynomials should not have horizontal asymptotes or vertical asymptotes. They should not have. And look at the form, right? So we said polynomials have this form, so x is the base, but for exponential, x is in the exponent, not in the base. So again, this is not a polynomial. The next one, no, again, so this cannot be expressed this way, so that's a polynomial. G, what do you think? Okay, so 3 is whole number, which is good. So this is power of 1 into whole number, that's good. But that's negative 1. Whole numbers start from 0. So you cannot have, because see, when you write x to the power of negative 1, you get what? 1 over x. Right? So you cannot represent this like that. So it is kind of a rational function actually, this one is. Right? So no. Let's look at h. Is it? No. This exponent is not good. It is not a whole number. How about I? Yeah. Yes. If you expand that, right, you can put it in this form. So which is fine. This is a polynomial. So we said this is not a polynomial. Next one. 1 over x plus 2? No. It has asymptotes. It's a rational function, not a polynomial. K? Yes. Oh, the arrows should be there. Okay. Yes, this is okay because see, domain is XCR and the range has a minimum but not minimum and maximum at the same time, so which is good. So this is a polynomial. L, no, it's a square root function. Power is 1 over 2. It doesn't work, so not polynomial. M, no, it has an asymptote. It's an exponential function, not a polynomial. N, no, it's a trigonometric function, a maximum and minimum at the same time. Okay. Example 2. Draw the graph of a polynomial function that has the following characteristics. So there are some points are given, right? F of negative 3 is negative 1. So when x is negative 3, y is 1. When x is negative 1, y is negative 2. When x is 4, y is 0. When x is 2, y is 5. Okay, so let's put those points. We're going to sketch a polynomial using these characteristics. So let's draw x and y axis and let's place the points, negative 1 and negative 3, no, negative 3 and negative 1, so here negative 3, negative 1 negative 1 and negative 2, 4 and 0, and 2 and 5. Okay, next characteristic, y intercept is 0. Okay, so let's place that point. Now, the next one, probably you don't know it yet. Let's discuss that. Okay, it says f of x is less than 0 when x less than 0 and when x is greater than 4. What do we mean with f of x less than 0? F of, huh? Negative, yes. Y values are negative. So y values are below the x-axis. So when x is less than 0, right? When x is less than 0, you need to sketch a graph that is below x-axis because y values are less than 0. Similarly, when x is greater than 4, same thing. F of x is less than 0, so you should draw something below the x-axis. The next item, f of x greater than 0, when x is between 0 and 4. So this time, f of x is positive. Y values are positive. Means you need to sketch something above the x-axis. Then x is between 0 and 4. Okay? So let's do that then. So we said it is f of x is positive when between 0 and 4. 0 is here, 4 is here. So I need to use the given points. So I need to have something like this. Okay? When x is less than 0, so I am here. So you need to draw something below the x-axis. I cannot go over, right? Above the x-axis. Okay? So I need to pass through the given points. I'm going to pass through this point. Now what I'm going to do? I cannot just go over because I cannot go over the x-axis. So I kind of need to go back. Okay? I make a turn and go back there to stay below the x-axis. So when x is greater than 4, same thing. I need to draw something below x-axis. And we have that. And domain XCR. So yes, we drew something, right? So that a domain is XCR. So let's look at some polynomial functions. So we have a table here. When degree is 0, you have a horizontal line. Okay? Let's say y equals negative root 3 or y equals 5. Some examples of 0 degree polynomial. And they will look like a horizontal line. They are horizontal lines. When degree is 1, those are linear functions as well, but this time they have a certain slope, right? They are oblique. Okay, so let's say we have this 2x minus 3. When degree is 2, so when we say degree, we are looking at the highest degree of that polynomial. Then you have a quadratic function. So you already know how they look like. Right? Parabola. When the highest degree is 3, we call them cubic functions. Okay, this is one example of an equation, and they may look like this. Okay, this example looks like this. Of course, there is arrows at the ends. Okay, if the highest degree is 4, we call them quartic functions. Okay, so the equation may look like this. The highest degree is 4. So they may look like this. Okay, if the degree is 5, we call them quintic functions. That's a example of a quintic function, equation of an quintic function. And this is how it looks like. Okay. So the related homework is here.